So in today's lesson, chapter 8.5, we are factoring. So we've taken a couple of lessons here to multiply polynomials times polynomials and expand and get larger polynomials, monomial plus monomial plus monomial. And so what we want to be able to do now though is take those monomials and we'll kind of go backwards. We'll use that same distributive property that we've used to multiply, and we'll factor polynomials. In other words, we're gonna take them apart. Okay, and then before we're done today, I will at least show you how to solve a quadratic equation if it's in this polynomial form. Okay, so some number a times x squared plus some number b times x equals 0. And equal, right, that means that we're dealing with an equation. Quadratic means we've got an exponent of 2. We can have exponents higher than 2, but then they're not quadratic. So before we jump in here, I want to remind us of what the distributive property with a monomial times a polynomial did for us. So let's take 2x and let's multiply it times x plus 2. Okay, this is what we've done. This was the first part of the chapter when we took just a single monomial and we distribute it to a polynomial, in this case a binomial. So the 2x wants to get multiplied times x, and we would have 2x squared, and then the 2x wants to be multiplied times the 2, and we've got plus 4x. Okay, so this is what we've been doing. We've been taking this distributive property and distributing into a parenthesis. And so what we want to be able to do now, though, is come from this form and let's get back into that parenthesis, that original equation. So I want you to notice here, looking at this final form, what do the 2x squared and the 4x have in common? Well, they have a 2x in common, so we're trying to take the 2x back away from it. Okay, so if we multiply to get in, then we've got to divide to get back out. And so if I take 2x squared and divide it by 2x, x is what's left over. And if I divide 2x away from 4x, that reduces to a plus 2. And so you'll notice what we ended up with is exactly what we started with. Okay, and that's undistributing. Okay, so if distributing is when we multiply, right, then undistributing, right, we're taking it out of it, is division, right? We take that largest thing they have in common and we divide it away from the two terms. So let's do one. Using the distributive property to factor the polynomial. So the first thing I want to ask myself is, between these two terms, 27x squared and 18x, what is the largest number they have in common? Okay, if I was thinking about common factors, what is the largest thing they have in common? Now there's a lot of ways that we can kind of play with these numbers to get those largest factors out, and we can talk about those if we need to. Some of us will be able to look at 27 and 18 and say, oh, well, those have a 9 in common, and 9 is the largest thing they have in common. Now here's the other part that won't be quite as intuitive maybe, but remember we're talking about the largest number of things they have in common. So we can see that they both have x's. And if the question is what is the most that they have in common, the answer is 1x. This one has 2 x's, x times x. This one has 1x. And so in common, the most they have in common is just 1x. Okay, and so that's what we've got to get used to doing. So 9x is going to be the factor that we divide out. And so let's take 9x and let's divide it away from 27x squared. So 27 over 9 reduces to 3. x squared over x reduces to x. And now we have the 9x factored away from our first term. Let's take the 9x and factor away from this term. 18 over 9 is positive 2. X over x goes away. And this would be the factored form. These we can check, because if I wanted to redistribute, I should get back what I started with, that 27x squared plus 18x. So, and again, I don't always do the check step, but this is the check step. So if I were to try to take the 9x and put it back in, 9 times 3 is 27, x times x is x squared, 9 times 2 is positive 18, and x times nothing else is there is x. And this is what we started with, and so we feel really good about this being our factored form. Okay? We're taking out, we're undistributing what they have in common. Okay? So I want you to give this one a shot. Find out what they have in common, and then let's factor it out. Let's take it away. Let's divide it out. So they have a 12x in common, and that should leave us an expression in parentheses. So when the 12x is factored away from our first term, the only thing left was an x. And if you wanted to put one x there, you could. And if we factored a 12x away from here, 36 over 12 is a positive 3, and the x's cancel. And then this would be your factored form. Again, you can distribute again, you can redistribute to check your answer, but this is the factored form. Okay? Now, don't get too comfortable, but don't get too scared either. They do get a little more complicated. They do get larger. We involve more variables, numbers change, exponents change, all that happens. Let me walk through this one with you, and then we'll give you a chance to do some of these in class. So between 4 and 8 and 2, they have a 2 in common. A squared, A, and A. If we're talking about in common, there's only one A in common, and we would see the same thing with the B. There's only one B in common. So now we've got this parenthesis, and 2AB is being divided away from each one of these terms. Okay? So we'll simplify each one of those smaller fractions to get to what's left over, right? So we should have negative 4 over 2 would be negative 2. A squared over A would leave an A, and the B's went away. Negative 8 over 2 is negative 4. This time the A's went away, and we had B. And then plus 2AB over 2AB, everything went away, but we do still have a 1 sitting there. When everything reduced, 1 was left over. Now, one of the ways we know that we're done is because there's nothing else in common with these terms. If there was anything left between 2 and 4 and 1, if there was anything left between the variables, A and B and none, if there was anything else in common, we could still take something else out. There's not anything else in common, and so this would be our what we call our fully factored form. Fully factored. Everything that could come out has come out. Okay. Now, one of the other methods that we'll use to distribute is called factor by grouping. And right off the bat, it's not our go-to. It's not the first thing we look at. But if I tried to factor this one, 4, 8, 3, and 6, there's not anything in common with all 4 of those numbers. We have an X here and an X here, but not here or here. We have Y's here and here, but not here and here. So with all 4 of these terms, there is no greatest common factor. Okay, so you might look at this and say, okay, well, this is fully simplified. There's nothing we can do. But here's another method of factoring that we have to look at, and it's called factor by grouping. Okay, so what we do here is let's just look at these 2 terms and see if they have anything in common. Well, they do. They have a 4 and a y in common. Okay? So, if the 4y is factored away from here, there's only an x left. If the 4y is factored away from here, there's a plus 2 left. So that's factored. Okay? What about these two terms? Do they have anything in common? Well, they do. They have a positive 3 in common. And if that positive 3 is factored away, then we have an x and a plus 2. Now that's interesting, okay? And I big picture here, now we have this monomial and we have this monomial that also now have a factor in common, and this will take some playing, but notice that those two groups have an x minus 2 in common. And if the x minus 2 is factored away, 4y is left over. And if the x plus 2, my bad. If the x plus 2 is factored away, there's a plus 3 left over. And this is factored form. Again, our goal in this part of the chapter is to try to get everything into a factored form. And on the next slide or two, you'll see why we're trying to factor. Factor by grouping takes a while. We'll play with it. It'll take a little bit to recognize when. But we're still looking for things that are in common that we can divide away, right? Distributing is when we multiply into a set of parentheses. Factoring is when we divide it back out. Remember, doing, undoing. Multiplication is the doing. Distribution is the doing. Division is the undoing. Factoring is the undoing. So here's another one. I want you to give this one a shot. This is factor by grouping. And so you give this one a shot, see what you can come up with. Okay. So there's a 3x in common right here. And when the 3x comes out, y is left over. And when 3x comes out, plus 5 is left over. And between these two terms, there's a plus 4 in common. And when 4 goes away, there's a y and a plus 5. And so now with these two terms, there's a y plus 5 in common. And when that y plus 5 goes away, there's a 3x plus 4. And that's what you should get. That is our fully factored form. And again, if we wanted to redistribute and check, we could redistribute and check, and we should get right back up here. Okay. Now again, all of this factoring is happening because we want to be able to use this zero product property to solve equations. I need for my equations to be in this something times something equals 0 form. And if I can get something times something equals 0, then I can solve. And I can solve by saying, okay, well, if my answer is 0, then either A equals 0 or B equals 0, but those two things have to happen. I have to be in factored form before that works. Okay, so when solving an equation, I first have to be set equal to 0, and then I need to be in factored form. This one is already in factored form. 2x plus 6 times 3x minus 15 is factored form. We already have two sets of parentheses, a binomial times a binomial, equal to 0. So this is kind of the end goal here. And once I get to this end goal, I want to be able to say 2x plus 6 equals 0 and 3x minus 15 equals 0, and then solve those two equations for the solution to my quadratic here. Okay. Now we've solved equations like this for a very long time. Subtracting 6 from both sides, dividing both sides by 2. Negative 3 would be one of my solutions, and 5 would be my other solution. And so if I take negative 3 and plug it into both of those x's, I'm going to get a 0 as my final answer. And if I take 5 and plug it into both of those x's, I'm going to get 0 as my answer. Okay, so that's what we're trying to do here. Let me do one here that's not already set up that way. So here we go. I am already set equal to 0, and that's one of the things I need to do is I need to be equal to 0 on this one side. If I'm not, then we'll have to make some algebraic manipulation to get equal to 0. But I'm already equal to 0, and so my question has to be, can I factor this little expression here? Does 8x squared minus 40x have anything in common? Well, they have an 8 and an x in common. And when the 8x is undistributed, I'm left with an x. And when the 8x is undistributed, I'm left with a minus 5. And so now I have something times something equals 0. So one of my solutions is 8x equals 0 or x equals 0. And then x minus 5 equals 0 or x equals 5. Okay, so let me do this real quick. And again, we don't check a whole lot, but here we go. So 8 times 0 squared minus 40 times, wait, that's 40. 40 times 0 equals 0. Is that a true statement? Well, sure it is. 0 minus 0 is 0. Okay, so this one worked out. What about 5? Check out 8 times 5 squared minus 40 times 5. And I believe you're going to get 200 minus 200, which is 0. And so both of these check out as solutions to my equation. This is where we're headed. We want to be able to solve quadratic equations and then check and make sure that our answer is indeed our answer.